What's going on, everybody? Welcome to a data science slash a data analysis tutorial series with the Python programming language and the Pandas library. If you don't know what Pandas is at the most basic level, it's just a library that helps you interact with row and column type data. I think the best way to learn something like this is just to jump into it, so I'm not really going to explain much more than that. So let's go ahead and get into it. What we're going to be doing in this series is just playing with a variety of data sets, and I'm just going to hopefully get you guys comfortable and familiar with interacting with the Pandas library. By no means can I teach you everything there, so if you just go to Google and type like Pandas Python docs or something like that, in fact, you'll probably land maybe even at the home page or something like that. But then if you go to documentation and then go to the API reference, here is where basically all the things you can do in Pandas is listed out for you. So definitely go there and just kind of go through everything. So first of all, I'll talk a little more on that, but the first thing we should probably do too is open a command prompt and let's install all the things that we're going to be using. So go ahead and do a pip. Make sure pip is corresponding to hopefully Python 3. I'll probably use F strings here at some point, so hopefully 3.6 or greater. I'm going to be using Python 3.7, and then Pandas, the version will be 0.24.1 unless there's been an update in like the last day. But if you're having some sort of deprecation or warning issues or whatever, check it out in 0.24.1 if you need to. And if you don't know how to do that, you could always say pip install pandas equals 0.24.1 or something like that. But don't do that unless you're having a problem and you want to see if it's you making a mistake or it's like a new version. So anyways, we're going to do pip install and hopefully spell install correctly. Pandas. We're going to grab matplotlib, so pandas for data analysis stuff, matplotlib for some basic visualization. We're not going to make this a matplotlib tutorial series by any means, but there's some cool quick things we can do with matplotlib, so we will. And then I'm going to be using Jupyter Lab. I've already got Jupyter Lab installed, so I'm not actually going to try to install it. It wouldn't matter anyway. But that's the editor I'm going to use. It's just an interactive Python notebook type of editor. If you want to use PyCharm or Sublime Text or whatever the heck idle you want to use, doesn't matter to me. I do like interactive Python notebooks for data analysis because it lets you kind of poke around. But you can get yourself a little screwed up and like modify a variable later and then get things out of order and get a little confused. So if you don't want to do that, that's totally fine. But I kind of like them for data analytics. So anyways, at least these two things and then Jupyter Lab if you want that as well. So while that's installing, we'll just talk about a couple of things involved here. And also let me check the version just to make sure. Panda, yeah, there it is, 0.24.1. Okay, so while that's installing, let's talk a little bit about how Pandas works. So basically you're going to read in anything that has a rows and columns sort of structure or could have a rows and columns structure. Things like JSON, for example, isn't quite rows and columns if you were to look at it, but that's what it is, or at least it can be. Not all JSON is. Because you also want to have everything have the same number of columns, but you can have JSON do that. Same thing with like a Python dictionary, for example. That's not even listed here, but there's a toDict, and I'm pretty sure from dict. And then all kinds of things like Excel documents, CSV, SQL, even BigQuery. They've got HTML, HDF5 documents, so you can read in. And then the other cool thing is you can push out. So sometimes I've used Pandas purely as a converter, so to just take data from one format to another. So SQL to JSON, for example, I've done that because it's just really quick to convert it, right? Same thing, like, or especially like HTML to SQL, because like with JSON we actually can do that pretty quickly and easily with like a dictionary and then JSON or whatever. But something more like from a table to SQL or something like that, if I just want to do something really quickly when I'm working, I'll end up using that. Google BigQuery is also pretty cool because that's new. I haven't actually seen that. I've never actually used BigQuery here, and I wonder how good it is, like if it'll load in batches or not. I actually don't even know, because that's really challenging, and I'm just finding out for the first time that this supports BigQuery. So cool. All right, it looks like we got everything installed, so I can quit yapping. We are going to use datasets here from Kaggle. It's not sponsored or supported in any way by Kaggle. It's just a cool place to get datasets. They have like a bajillion. Yeah, that's a real number, by the way. If you just go to kaggle.com, make an account, come to Datasets, and then you can just kind of poke around if you want. There's 14,590 datasets right now, but there's always new ones coming in. We're going to be using the avocado dataset first. If you didn't know, avocado is actually a fruit. Fascinating. Also, most closely a berry. Would not expect that. Imagine getting like a fruit salad, and it's like avocado, or fruit flavored something, and it's avocado. So anyway, we're going to be using the avocado prices dataset. So go ahead and grab that, download. You have to have an account to download it, so make an account. And then a lot of times on these datasets, kind of cool, they have like some explanation. A lot of times this one doesn't really quite have the greatest explanation ever, but most of them do. And then this is just kind of like a quick visualization, and this is a lot like what Pandas is going to look like, minus this kind of distribution stuff, which that's also pretty cool. But Pandas doesn't do that for us, but it gives us like a little table like this. So that's kind of neat. Let me think here. Oh, the other thing I would want to show you guys is the kernels. A lot of datasets, people can write kernels, which is basically a Python notebook. So you can see what other people are doing with those datasets and learn even more, because most of the time they're going to be using Pandas. And then other things on top of Pandas, maybe at scikit-learn, which is what we'll use scikit-learn towards the end. XGBoost is really popular, or maybe TensorFlow, Keras, that kind of stuff. So once you feel comfortable and you really want to see like how good are you, or what kind of things are you missing in terms of doing data analytics, and then maybe later doing like predictions, stuff like that, you can always go to the competitions on Kaggle. I think this is the best online, like in terms of online coding competitions being applicable to the real world, this is the best place, because these are actual things that companies want solved, and these are things that companies will ask you to solve if you go work for them, either as an employee or contractor, consultant, whatever. Okay, so download the Kaggle avocado dataset. I'm going to put it in a directory literally called Datasets. So Datasets, there's my my avocado. So now what I'm going to do is go ahead and run JupyterLab. To run JupyterLab, you literally just open up a command prompt to go to the directory that you're working in, then just type JupyterLab. That'll open up in your browser. I'm going to go with Notebook. Again, though, if you want to use your own editor, whatever, go for it, man. I don't care. Or lady, I'm not judging. I'm actually at 10% gender split, so that's pretty exciting. Or sex split? Anyways, watch out. Comment. I'm not reading the comment section anymore after my statements. Anyway, import pandas as PD. This is just kind of convention that we denote pandas as PD. That's just a standard that people do, and you're going to see this in a lot of people's code. The next standard is df. Generally, if you're going to define a data frame, it's going to be called df. Now, if you're going to have conflicting names or something like that, you might say avocado underscore df or something like that. But most of the time, you'll just see df. Short for data frame, and data frame is just the object that is your columns and rows. There's also a thing called series, which is just like a single column, and then there's a thing called panel, which I almost never see anybody making use of, except in really more advanced use cases, and we're never going to use a panel. I can't say we're never in this series if I like add stuff to it, but at least in what I foresee for this series, we won't even touch panel. But panel is just like multiple data frames, so it's like a three-dimensional, right? So rather, it's like columns, rows, and then depth. Anyway, df equals pd dot read underscore CSV. So this is a function we can read CSV, and then later we could do something like df.toCSV and save it out as a CSV, and we'll do stuff like that in a little bit. But for now, we're just going to read CSV, and datasets slash avocado.csv, and we'll just read that in first. So that works, and we could just like print out a data frame, but as you can see, it always prints out just like gobs of information. And like as we edit and modify this data frame and work with it, we want to be able to debug. Often, like you might say, like you might print something out in Python, but this is a lot. So what you can instead do is use .head. You'll see people using this a lot, and all that is just so we can kind of see a quick snippet. And this will be the first n rows. Default is 5, but you can always change that. So we can say 3, and then boom, you get that. Alternatively, sometimes you'll do some calculations, especially on like chronological data, where you'll use like a moving window, and head won't be good enough. You'll actually want to see like maybe the end. So you like the foot maybe, but instead we call this df.tail 2 or something. You can put anything you want in there, same sort of thing. And you can go bigger than 5 too if you want. So, so that is just a way for you to visualize. So as you can see, we've got quite a few columns here. We've got date, average price, total volume. This is like how many avocados were sold that day. These are specific PLUs, I want to say. And then, is that right? Hopefully that's the right term. Anyway, total bags. I'm not really, like, I guess bags. I don't know. Not all of this data is something I'm totally curious about. And then there's type, which will bite us in a little bit. And then I guess the region they came from. Anyway, just a quick simple data set for us to play with, not really get too advanced into. But anyway, what we're going to do is now, like if you wanted to reference a specific column, you could say something like this, df, and then use square brackets, and then in quotes, so kind of like you would a dictionary. df, we'll go average price. So as you can see, this just kind of prints out to us the average price. And again, the same thing we can do is .head, just to get a snippet of what we're working with. So now the next things that we can start to do get a little fancier. Now, also, let me show you one more thing before we go on. So aside from using the brackets and the quotes, the other thing we could use is this dot notation. So you could say average price dot head as well. But nobody does this. Don't do this. I mean, I might have seen someone use this syntax like one time. Just know it exists. And so like sometimes a column name might actually be something that you think is a pandas method or functionality, and it's not. It's actually the person's column name, and you just were none the wiser. And that's kind of why I think it's better to use this terminology instead. I'll leave that there. But why it's better to use this, because this is totally clear. Anyone reading your code understands average price is a column name. Because imagine you could have this called like, you could have it called mean or something like that, where people are like thinking, oh, it's an average. It would be very confusing. So anyway, use that one. But no, this one exists, unfortunately, but don't use it. So the next thing that we could do is go by like a specific region. So like in this case, we can see there's many regions. What we can do is like we can separate out a very specific thing in these columns. So there's probably a bunch of regions, and later we could get a list of like all the regions, and we'll talk about that. But let's say we just wanted just the Albany region only. How could we do that? Well, we could say instead, and so now we're gonna have like the main df, and then we're gonna make a new data frame. So now we'd probably like to say something a little more like Albany df. Okay, so that'll be our new data frame. We're gonna say that's the data frame where the data frame region is equal to Albany. So this looks a little confusing, but it's really not. It's just the main data frame where, in these brackets, the df region equals Albany. And that's it. So now Albany df.head. And now you can see, okay, so this is only where the region is Albany. Now let me just make some more space here, just so I don't have to keep typing at the bottom and scrolling down. Okay, so now the next thing is, okay, first of all, we got a couple of issues. We've got like useless over here, and we can see here that this bold here, that's actually our index. So like if we said Albany underscore df.index, Albany, there we go. It's a worthless index. What is the index? Well, the index is it's exactly what it sounds like. What is this data indexed by? So how do each of these columns relate to each other? And hopefully the index is a unique identifier, kind of like you would have like a unique identifier in any database or something like that. It doesn't necessarily have to be, but it should. So most of the time. So in this case, what is the one thing that all of these are kind of related by, right? These are all avocado. This is avocado prices and volumes and stuff, blah, 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 over time. So they're all indexed by date, or they should be indexed by date. And actually, it's pretty clear that was the original, like, leftmost meaningful column. So that's what probably was the intended index in the first place. So the problem is a CSV doesn't have any sort of meaning about index. So like, for example, if we just opened up this actual CSV file, let me just open it with, not Notepad and WordPad, I'll tell you that, in here. So we can see here, this is a CSV file. This is the raw data that we're loading in. Now, it does have apparently this like meaningless column number, which is pointless. And we'll talk later about how we can handle for that, but mostly we just want the date to be the index. We're not really worried about extra columns. So there's a bunch of different ways as we like load data in, and later we can drop columns, blah, 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 blah. But for now, we're not worried about that. We'll handle that later. I just kind of want to show you guys a quick rundown of ways we can manipulate data with pandas. So anyway, we want a meaningful index. So what are we going to say? We're going to say Albany_df.set index as date. Did I type Albany again? God. Okay, so now it's indexed by date. Now, unfortunately, that looks like our date is, I guess, yeah, it's in just a weird order, unfortunately. But anyway, so we've set index as date. Now, the next thing I want to say and show is, what if we said, okay, now Albany, oh my gosh, I can't type Albany. I was trying really hard. Anyway, we'll do the head again, and what just happened? We lost the date. So this is like your first exposure to pandas in its nonsense sometimes. It makes total sense, but it's confusing the first few times you deal with it. So with pandas, a lot of these operations, what they do is actually return a new data frame. So let's go back up here. So you can even see it happened right here. We just said .set index date, and then we didn't ask it to display Albany data frame. It just it didn't print it out, but it just displayed it because that's what this set index does. It returns a data frame. So so we have two options when we want to perform most things. I will say some of the commands will just by default be what's called in place, and then others don't have an option to be called in place. You actually have to redefine. So there's two things that you can do though with something like set index. One thing you could say is Albany df equals Albany bro. This is the worst. Albany. This is horrible. Okay. Albany df dot set index date. Dude, maybe I just shouldn't be doing a tutorial today. I don't know. So now you can see nothing got printed out for us. Nothing got displayed. So because instead, well, we just reassigned basically. So now Albany df dot head. I did it. Now it is actually done. So the next thing that I could show you as well is your other option was to do something like this. You could say instead Albany, actually Albany df.head. I'll let that stay there, but then I just want to show down here an example of the other way you could have done it. Albany df.set underscore index, and then you would set the index as date, and then you would say in place equals true. So this will actually modify the Albany data frame in place, so you don't have to do the reassignment. But we've already set the index as date, so that's not going to do anything for us. So we're all done. Now, the next thing I want to do is show you graphing. So one thing we can do is just immediately graph this data. It's going to look horrible because it's clearly like not quite in like decent order. So anyway, what we could say is Albany underscore df dot plot, and we can immediately plot things. And in fact, this will be I'm tempted to just do it. I just kind of want to see what it does. Shoot, I forget the there's like a little short, you can just there's a shortcut that you can run in, it's like the % thing. I'll get it right for the next tutorial. Anyway, there's a thing you can do in Jupyter notebooks that will just display the graph immediately. In that case, if you just see something like this, just like run it again and it'll pop up. Anyway, so as you can see here, we can plot stuff like immediately, or you can plot really specific columns. So you could say, hey, I want to plot average price, and it'll plot average price. I will just say right out of the gate, this is not a correct plot. We've got other issues going on in terms of the date and then also some other things, but we'll get to that in a little bit. So I think for now, that's everything. If you've got questions, comments, concerns, whatever, feel free to leave them below. Otherwise, in the next tutorial, we're going to talk a little bit more about how we can actually modify this data and work with this data, and and fix this graph and all that. But there's a whole lot of stuff for us to cover, and I don't want to keep making part one super long. So quick shout out to the recent channel members, Jire, Dinesh Kumar, Nikesi Weki, and Chris Olin. Thank you guys very much for your support. If you don't know how you can become a channel member, you can click that beautiful join button underneath the video if you want. Otherwise, questions, comments, concerns, whatever, feel free to leave them below. If you want, you can come join us at discord.gg/Centex. Either come hang out or get help with other stuff. Anyway, till the next video.